So welcome. Here we are going now to illustrate how to solve second order linear differential equations. So example 1, solve so A is y prime double prime plus 3y prime minus 4y equals to 0. Solution. So let's assume that suppose that y equals to e raised power r x is the solution. So this means that y prime is r e raised power rx and y double prime is r squared e raised power r x. So replacing these values in the given equation, we get, so where there's y double prime, we put r squared e raised power rx plus 3 y prime is r e raised power rx minus 4 e raised power rx equals to 0, which will give us r squared plus 3r minus 4 and e raised power rx equals to 0. Now, since exponential cannot be 0, this implies that r squared plus 3r minus 4 equals to 0. Actually, this is what we call characteristic. Equation. So from the characteristic equation, you get the characteristic roots. So this is simply a quadratic equation. So let's see, product, this can be solved. Product is minus 4, sum is 3. So numbers, we have minus 1 and 4. So this will be written as r squared minus r plus 4r minus 4 equals to 0. Pair this, pair this. So r into r minus 1 plus 4 into r minus 1 equals to 0. So we have r plus 4, r minus 1 equals to 0. So which means r equals to minus 4 or r equals to 1. So therefore, y1, actually I can call this one r1, r2. So y1 is e raised power minus 4x and y2 is e raised power 1 times x, just x. So remember, by definition, y1 is e raised power r1x and y2 is e raised power r2x. So by superposition principle, the general solution is y of x equals to c1 e raised power r1x plus c2 e raised power r2 of x. So therefore, y of x is given by C1 e raised power minus 4x plus C2 e raised power x is a general solution. So this is what we have. Actually, this was the case of two distinct real roots. Now, example 2, B, we have y double prime minus y prime plus minus 2y equals to 0. Again, we let y equals to e raised power r x be the solution. So this means y prime will be r e raised power r x, and y double prime is r squared e raised power r x. So using these values, if I call this one star, star becomes, so where there's y double prime, I put r squared e raised power rx, y prime is r e raised power rx minus 2 e raised power rx equals to 0. Now, r squared minus r minus 2 multiplied by e raised power rx equals to 0. Now, exponential cannot be 0, so this means r squared minus r minus 2 equals to 0, since e raised power rx is always non-zero. So this is what we are calling the characteristic equation. So from the characteristic equation, you get characteristic roots, and this is just a quadratic in R. So product is minus 2, sum is minus 1. Two numbers whose product is minus 2, sum minus 1 is minus 2 and 1. So we'll have r squared minus 2r plus r minus 2 equals to 0, which will be r into r minus 2. Common here is 1, r minus 2 equals to 0. So I'll have r plus 1 into r minus 2 equals to 0, which means that r is minus 1, or actually I can say and say r1, r2 is 2. So this means y1 is e raised power r1x, which is e raised power negative x. And second solution, y2 is e raised power r2x, which is e raised power 2x. Now, general solution by superposition principle, y is given by c1 y1 plus c2 y2, i.e., the general solution is y of x is given by c1 e raised power negative x plus c2 e raised power 2x. So this is the solution to that problem. C, we have y double prime plus 2y prime plus y equals to 0. Now again, we let y equals to e raised power rx be the solution. So this implies derivative is r e raised power rx, and second derivative is r squared e raised power rx. Now, using these values, if I call this one star, using these values, star becomes, so as a second derivative, you put r squared e raised power rx plus 2 r e raised power rx plus y is e raised power rx equals to 0. So we'll have r squared plus 2r plus 1, and then you factor out e raised power rx, which is common, equals to 0. This implies r squared plus 2r plus 1 is equals to 0, since always e raised power rx can never be 0. So these are what we call characteristic equation. Now, from characteristic equation, you get characteristic roots. Now here product is 1, sum is 2, so the numbers will be 1 and 1. So I'll have r squared plus r plus 1 equals to 0. This pair and this pair. So r into r plus 1 into r plus 1 equals to 0. So r plus 1 equals to 0. So this means r equals to minus 1. Actually, there are two values for r. So I repeated root. So with this now, solution is y1 y of x is given by c1 e raised power r x plus c2 x e raised power r x. So this is by definition when we have repeated roots. So therefore, the general solution is y of x is given by c1 e raised power negative x plus c2 x e raised power negative x. So that is the solution to that particular problem. Our last example for this session, this D or E, this D, y double prime plus 4y prime plus 20y equals to 0, given that y at 0 is 3 and y prime at 0 is negative 1. Solution. So the first thing, let's get the general solution. So let y equals to e raised power rx be the solution. This means y prime is r e raised power rx and y double prime is r squared e raised power rx. If I call this one star, using these values in star, we get, so r squared e raised to power rx, and then plus 4r e raised to power rx, and then plus 20 e raised to power rx equals to 0. So r squared plus 4r plus 20 e raised to power rx equals to 0. So r squared plus 4r plus 20 equals to 0, since exponential cannot be 0. So this one, we have to use quadratic formula. R is given by minus b plus or minus square root of b squared minus 4ac over 2a. Remember, a is 1, b is 4, c is 20. So r will be minus 4 plus or minus square root of 4 squared minus 4 times 1 times 20 divided by 2 times 1. So it will be minus 4 plus or minus square root. 4 squared is 16. 4 times 20 is 80. And then over 2. So 16 minus 80, we get minus 64. Over 2. I remember square root of minus 64 is like square root of 64 times minus 1, which is square root of 64 times square root of negative 1. This square root of 64 is plus or minus 8. Square root of negative 1 by definition is I. So this will be minus 4 plus or minus 8i over 2. So which is the same thing as r equals to minus 2 plus or minus 4i. So complex conjugate. Yes. I remember if we have complex conjugate, just remember that if r is given by alpha plus or minus beta I, then y is usually given by c1 e raised power alpha x cosine of beta x plus c2 e raised power alpha x sine of beta x, which is the same thing as e raised power alpha x into c1 cos beta x plus c2 sine beta x. So in our case, alpha is minus 2 and beta is 4. So y will be given by e raised power alpha, which is minus 2x, into c1 cosine of beta x, which is 4x, plus c2 sine of beta x, which is 4x, is a general solution. But you are given that y at 0 is 3 and y prime at 0 is 1, minus 1. So what we do, we get the derivative of this function. So y prime will be, so this product will this as u and bracket as v. So u prime is minus 2 e raised power 2x times v c1 cos 4x plus c2 sine 4x, and then plus u, which is minus 2 e raised power minus 2x times v prime. Differentiating this, we get minus 4 c1 sine 4x plus 4 c2 cos 4x. Now, when x equals to 0, y will be e raised power minus 2 times 0, c1 cosine of 4 times 0, plus c2 sine of 4 times 0. So this is 1, because it will be e raised power 0. And then this is also 1, so just get c1, because this other part will be 0. So this will be the same as 3. So the value of c1 is 3. And then y prime at 0 would be negative 2 e raised power 2. Okay, so maybe there's a negative sign here. So negative 2 times 0 into c1 cos 4 times 0 plus c2 sine 4 times 0 plus here e raised power minus 2 times 0 into minus 4 c1 sine 4 times 0 plus 4 c2 cos of 4 times 0. And remember, that should give us negative 1 from the definition. So this would be negative 2 into, so this is 0, so this will be c1 plus this will be 1. This is 0, and then this is 4 c2, because cos of 0 is 1. This should give us negative 1. So negative 2c1 plus 4c2 equals to negative 1. But c1 is 3, so this implies minus 2 by 3 plus 4c2 equals to negative 1. So which implies minus 6 plus 4c2 equals to negative 1, which means 4c2 equals to minus 1 plus 6, which is 5. This means 4c2 equals to 5, divide by 4, divide by 4, which means c2 is 5 over 4. So therefore, the particular solution to this initial value problem is y of x is given by e raised power minus 2x into c1 is 3 cosine of 4x, c2 is 5 over 4 sine of 4x. And then this is the last step. Thank you.